Welcome students to the first video on Introduction to IoT. In this video, I, Smita Chaudhary, are going to discuss on various points related to IoT such as Introduction to IoT, Data Handling in IoT, Scope of IoT and IoT Communication Model. So let's start with the first point as Introduction to IoT. Now IoT comprises of the things that have the unique identities and they are connected to the internet. While many existing devices such as network connected or 4G enabled mobiles are connected to the internet, but the main focus on IoT is in the configuration, control and networking via the internet of device or the things that are traditionally not associated with the internet. Now, what are those devices which were not associated with the internet before? These devices includes thermostat, utility meters, Bluetooth connected headset, your irrigation pump, sensors or control circuits for electrical cars. So, in this section, we are going to discuss the more parameters related to the IoT. We just learned in the last segment that IoT comprises of things that have unique identities and connected to the internet. But then the question comes in our mind, is it the only scope of IoT of connecting the things to the internet? No, there is a widespread applications and the scope of the IoT. So in this segment, we are going to see the first point as the scope of IoT. The scope of IoT is not just limited for connecting the things to the internet. Rather, IoT allows the things to communicate and exchange of the data while executing a meaningful applications towards a common user or a machine goals. Now, exchange of data includes the control and the other information that could include a data associated with the user. Now, repeatedly we are using the word what called as a data. So, from where the data comes as? So, let's concentrate on the thing that is how the data is handled in the IoT. So, data itself does not have any meaning until it is contextualized process into a useful information. That is, till the time we extract a meaningful information from the data, that data doesn't have any kind of a meaning. So, application on the IoT network extract and create information from the low level data by filtering, processing, categorizing, condensing and contextualizing the data. After doing this one, now we are ready to move towards our actual objective. So this information is then obtained, is then organized, structured to infer the knowledge about the system, and then that's how we are going to actually achieve our objective. And the same thing is shown in a figure. The first block as a data, which is nothing but the raw and unprocessed data obtained from the IoT device or any kind of a system. We are definitely going to use the series of sensors which are connected to the different processors. Now that data is nothing but it is converted into information. So information is inferred from the data by filtering, processing, categorizing and condensing and contextualizing the data, and then the knowledge is inferred from the information by organizing and structuring the information, and it is then put into the action to achieve a specific object. So in this particular section we learn about the wide scope of IoT and how the data is handled in an IoT device. Now we just learn about the handling of the data, but is it the only task which is done in IoT? No. The next and most meaningful task is adding a meaning to the data. So to discuss the point, here we are seeing a raw sensor measurement data which is generated by the weather monitoring station. I have shown the two readings. We can consider that these are the two readings for the temperature and the humidity. But by looking to this number, we cannot say that which is temperature and which is humidity. meaning to the data, a context is added, which in this example can be that each tuple in data represents the temperature and the humidity. So with this context added, we know the meaning of the major data tuples now. Till that time, we cannot categorize or we cannot find out what is the exact meaning or what is the exact readings which is done by this weather monitoring station. After that, now the information is obtained by categorizing, condensing and processing this data. Now, for example, just I have shown the we have seen the example of series of a data. Maybe that data is taken at the interval of 1 minute, but it is going to take a vast space for storing this kind of a data. So what can be done? So the average temperature and the humidity readings for the last 5 minutes is obtained by averaging the last 5 data tuples. Now what action we can initiate by observing these kind of the data which is average for the last 5 minutes. So the next step is to organize the information to understand the relation between this piece of information. We can definitely go on adding some more features, like just by analyzing the data, we can go for adding the features like giving an alert at the specific average temperature. It's obviously going to depend upon where you have installed this weather monitoring system. I can definitely go on install this particular system in the greenhouse monitoring also. Now, in the next section, we are going to discuss about the application of IoT. The application of IoT extends a wide range of domains, which include home, cities, environment, energy systems, retail domain, agriculture domain, industrial application of IoT, health and life cycle. In this particular segment of the video, we are going to discuss these applications area, but they are not going to be the only application area of the IoT. Rather, there are many application area of the IoT. Now, the first one is the smart home. Now, IoT has the several applications such as smart lighting that adopt the lighting to suit the ambient conditions. Smart application that can be remotely monitored or controlled. I may going to have the gas sensing system to be installed in a kitchen, and I can have the alert of that particular gas sensing system on my mobile. So by sitting in an office, I will come to know whether the things are going well in my kitchen or not. Like the way I can make a complete home as a smart home. The next application is the smart city. Now IoT has an application such as smart parking system that provides the status update of the available slot of a parking or of the parking in a mall or in a market area. Or if I go further, then I can actually book that particular slot of a parking for me for a specific duration. That's how I may going to save my time. Again, I may go on implementing the smart lighting system in the park. That's how I'm going to reduce the electricity cost which is required in a parking one. The same can be installed. I may going to have the smart transport system, smart energy system, which make my city to be a smart city. Now, next application of IoT as in a environment. IoT has an application such as weather monitoring system, just which you have discussed in a data handling. Another one as the air and noise pollution control. I may going to have the forest fire detection system. I may going to have the river flood detection system. Like I said, the air and noise pollution system. The noise pollution system can be installed near the hospital area or near your school area. So that's how I may going to control these parameters. The next is the energy system. IoT has an application such as including a smart grid integration of renewable energy sources, and the prognostic health management system. The next one has the retail domain. Google
is one of Google Retail Home or Google Shop is one of the best example of this IoT application in a retail domain. In this particular shop, the person can walk in, take the product and simply walk out. There is nothing what called as a queue of doing the payment, because the moment I entered, I have the identity. With my identity, my bank connectivity is there, and if I go for purchasing of any product, automatically that amount is going to be deducted from my bank directly. So I may going to have the smart payment system. I may going to have the smart vending machine also. The next as the agriculture domain. The IoT has an application such as smart irrigation system that help in saving of water, which is also going to enhance the productivity. The same can be installed in a greenhouse. The picture shows that the different sensor nodes are installed in a big farm. They have their base station. They are going to communicate with their base station. What they are going to communicate with their base station? Definitely they are going to communicate the water level of the soil to the base station. Depending upon that water level, I may going to start, the system will automatically start the sprinkling. So that's how the complete system will be the humanless, and it is going to be monitored by the IoT device. One more application of the IoT as the drone. The drone is used for monitoring the crop condition. The next as the IoT in an industrial domain. Now, in an industrial domain, IoT can be used for monitoring the machine condition. I will have a system which continuously monitor the different parameters of the system, by which now I can monitor the condition. I will be able to predict the fault and determine the cause of the fault, as well as I can use the gas detection, fire detection system in a industrial domain by using the IoT. The next application of a IoT is in a health and a lifestyle. IoT has applications such as the health and fitness monitoring system. Those are nothing but the wearable electronic devices. I have shown the picture of wearable watch, which will be used for monitoring the health, heart rate, blood pressure. Also, it will tell me the number of step count of the day. So that's how I'm going to use this particular device for monitoring my health condition. Again, I may going to have the saline monitoring system which are installed in a hospital. Again, I can have the patient monitoring system. The app will be installed on the doctor mobile, and now by that app, now the doctor can monitor the condition of the patient 24/7. So these are some of the applications of the IoT which I have listed, but there are many applications of the IoT. There are many ways of giving the definition of the IoT. The one which I am giving is given in a book. A dynamic global network infrastructure with a self-configuration capabilities based on standard and interoperable communication protocols, where physical and virtual things have identities, physical attributes, and virtual personalities, and use an intelligent interface and are seamlessly integrated into an information network, often communicate data associated with the user and their environment. To continue with this segment, we are going to see the next as the logical design of the IoT. The logical design of the IoT system refers to an abstract representation of the entities and process without going into the low-level specification of the implementation. So in this section of the video, we are going to describe the functional block of an IoT system. Now the functional block. An IoT system comprises of the number of functional blocks that provide the system capabilities for identification, sensing, actuation, communication, and the management. The diagram shows the same. Now let's see these functional blocks one by one. The first one as the device. An IoT system comprises of the device that provides sensing, actuation, monitoring and control function. Next as the communication block. The communication block handles the communication of the IoT system. Services. An IoT system uses various types of IoT services such as services for device monitoring, device control services, data publishing services, and services for device discovery. Management. Management functional block provides various functions to govern the IoT system. Security. Security functional block secures the IoT system and by providing the functions such as authentication, authorization, message and content integrity and data security. And the last block as the application. The IoT applications provides an interface that the user can use to control and monitor various aspects of the IoT system. Applications also allow the user to view the system status and to view and analyze the process data. In the next section, we are going to study the different IoT communication models. The first one as the request-response model. The request-response is a communication model. Request-response model is a stateless communication model. Each request-response pair is independent of each other. In this model, the client sends a request to the server and the server responds to the request. Now, when the server receives a request, it describes how to respond, fetch the data, retrieve the resource representation, prepare the response and then send the response to the client, and that's why it is called as the stateless communication model. The diagram for the same is shown. This is the client which sends the request to the server. Servers do the functionality of process request and send the response to the client. It uses the resources. The resources are used by the server. The next model as the publish-subscribe model. Publish-subscribe is a communication model that involves publisher, brokers and the consumers. The publishers are the source of the data. Publishers send the data to the topic which are managed by the broker. So broker comes in a picture here. Publishers are not aware of the consumers. Consumers subscribe to the topic which are managed by the broker. When the broker receives the data for a topic from the publisher, it sends the data to all the subscribed consumers. This is what the communication model. You can see the publisher, broker and the different consumers. The next communication model as push-pull model. Push-pull is a communication model in which the data producers push the data to the queues and consumers pull the data from the queues. Producers do not need to be aware of the consumers. Queues help in decoupling the message between the producer and the consumer. Queue also acts as a buffer which helps in the situation when there is a mismatch between the rate at which the producer pushes the data and the rate at which the consumer pulls the data. This is what the communication model. You can see the publisher who push the data on the queue which is received by the consumer. So it is not at all necessary that the publisher and the consumer should operate on the same speed. Exclusive pair model. Exclusive pair is a bidirectional full duplex communication model that uses a persistent connection between the client and the server. Once the connection is set up, it remain open until the client send a request to close the connection. Client and server can send a message to each other after connection setup. The exclusive pair is a stateful communication model, and the server is aware of all the open connections. Here is a diagram of the exclusive pair model. We can see the client and the server. The first request which is sent by the client for the setup of the connection. In response to that request, now the server will accept the request. Now the connection is set up between the client and the server. Now the message is going from client to server. In response to the message, the server will send the messages. The connection will be open till the time client send a request for closing that connection. So this is all the IoT communication model. In this segment of the video, we are going to discuss IoT Enabling Technologies. Now, IoT is enabled by several technologies, including wireless sensor network, cloud computing, big data analytics, embedded system, security protocols, architecture, communication protocol, web services, mobile internet, and many more. Now, this section provides the overview of some of these technologies. We'll start with the first one as WSN, which stands for Wireless Sensor Network. Now, wireless sensor network comprises of distributed devices with sensors which are used to monitor the environmental and physical conditions. These sensors are going to be installed at the various locations. Now, a WSN consists of several number of end nodes and routers and coordinators. In the example of agriculture, application of IoT in agriculture, in a previous section, I have shown you number of such nodes. Now, end nodes have several sensors. End nodes are nothing but the several sensors attached to them. Now, end node can act as a router also. End node can act as a router also. Routers are responsible for routing the data packets from end nodes to the coordinators. Now the coordinator collect the data from the nodes. Now, coordinator also acts as a gateway that connects the WSN to the internet. Now, some examples of the WSN used in a IoT system are weather monitoring system, indoor air quality monitoring system, soil moisture monitoring system, just which we have discussed in a agriculture domain, surveillance system, smart grid, and structural health monitoring system, which also uses a WSN to monitor the health of structures like buildings, bridges by collecting the vibration data from the sensor nodes which are deployed at the various locations in the structure. Now, after the WSN, that is wireless sensor network, let's take the next one as cloud computing. Cloud computing is a transformative computing paradigm that involves delivering applications and services over the internet. Cloud computing involves provisioning of computing, networking, and storage resources on demand and providing these resources with different services to the user in a pay-as-you-go model. The cloud computing resources can be provisioned on demand by the user. The process of provisioning resources is automated in case of the cloud computing. Then the next as the big data analytics. The big data is defined as the collection of a data set whose volume and velocity means in terms of its temporal variation or variety is so large that it is difficult to store, manage, and process and analyze the data using a traditional database and data processing tool. Big data analytics involves several steps starting from data cleaning, data meaninging, data processing, and visualization. The next one as the embedded systems. Now, embedded system is a computer system that has computer hardware software embedded to perform a specific task. Now, how it is differ from the personal computer? Then, embedded systems are designed to perform a specific task. The key components of an embedded system include microprocessor, microcontroller, memory, networking unit, and input-output unit storage. With this, I will complete this video. I have taken the content from the book Internet of Technology, a hands-on approach by Arshdeep Pagga and Vijay, which is the first textbook of your syllabus. I have taken some of the images from these websites. Thank you for watching the video.